Hey there, everybody. Welcome back. We're doing Math 335 today. Well, this hour. And the last content you were looking at was on linear equations and then complex stuff. So I thought that we'd hit on a little bit of each. Complex numbers. So let's just warm you off with something simple. How should I go about solving that? We add the 5 to both sides. That's a great thing to start with. I always recommend doing the adding and subtracting first, not the multiplication and division. If I do that, I add it really to both sides. That way we're doing the same operation to both sides. We're left with 2x on the left because the -5 and +5 cancel out. And on the right, we have 7 + 5 is 12. Now, we can divide by 2. If we do it on this side to get rid of it, we got to do it over here. So 2 divided by 2 cancels out. We're just left with 1x, so we have x. And 12 divided by 2 is 6. Another alternative you have, when you have the 2x equals 12, is not necessarily dividing by 2, but multiplying by the reciprocal or multiplying by 1/2. These two are identical steps. And sometimes multiplying by the reciprocal is the easier way to go. Like we'll see in the next fraction. Did I say fraction? I did say fraction. Let's kick it up a notch. Let's go 3/4 x minus. Ooh, let's do that. What should we do here first? That is what I would do right now first. Rather than moving or adding or subtracting, I hate fractions. So I would do my best to clear fractions. Fuck them, get rid of them. So to do that, multiply by the lowest common denominator, as you were saying. So if I wanted to figure out what it is, any denominator would work that cancels off the 4 and 6. The lowest one, though, is 4 is 2 times 2, 6 is 2 times 3. The LCD, 2 times 2 times 3 is 12. So I'm going to multiply both sides by 12. And rather than just do multiplying it over, I'm going to put like 4 times 3 on the top here. And the reason why I'm doing that is the 12 factors into 4 times 3, and I need to get rid of a 4 on bottom. I need to get rid of a 6 on bottom on the other one. So I'm going to write 12 as 2 times 6 up above it. That's my way of distributing it to each one. And then I can start canceling stuff out. The 4s will cancel out, and I'm left with 3 times 3x minus, and then I've got the 6 cancels out, and I have 2 times 5 left. And then I've got, of course, 1 times 12. If I do that multiplication, I get that. And now we're back to the step that sends me likes. We'll add to both sides. And then we'll divide by 9. I would try to see if this simplifies. 22 is 2 times 11 and 9 is 3 times 3. Nothing cancels. So I'm going to leave it as that x equals 22 over 9. I'm not going to bother with a decimal or anything like that. It's just simple the way it is. Doesn't need changing. You guys ready for more? How about you, Chris?
I'm ready.
All right, let's maybe add some shit to it. Now, what should I do here?
Get rid of the fractions.
I like that. Let's do that. So, 2 and 5 are both prime numbers. So the LCD is going to be 2 times 5, which is 10. So I'm going to multiply both sides by 10. And I got to hit each spot. And for the 10, it's helpful to remember it is 2 times 5 for when I want to cancel stuff in a denominator. Distributing it to the 4 is just going to give me negative 40. And the same thing with that 2 is going to be plus 20. The real issue comes with distributing to the fractions. And so the 10 is 2 times 5. I've got a 2 on bottom. I'm going to use the 2 here from the 10 to cancel the 2 on bottom, and I'm left with 5 times 5. So 5 times 5 gives me 25x. And I'll do the same thing over here. I have a 5 on bottom, so I'm going to cross off the 5 there with that 5, and I'm left with 3 times 2, which is 6x. Now what? Get the like terms on the same side, right? What do you want to move? We have options.
The 6x.
You want to move the 6x? I like moving the 6x. I very much approve moving the 6x over moving the 25x. Not just because the letters are on the left, but then I end up with a positive number in front. That's pretty important to me. Is there anything else we should do? Since we moved the variables to the left, we should move the constants to the right. And we can do it in the same step. We don't need to waste a bunch of paper, do multiple lines. And finally, the division here is pretty easy. It doesn't mean it's pretty, but we're just going to divide both sides by 19. And we get x equals 60 over 19. Yes. You can always just multiply the two numbers. You can always multiply all, if there's like 4 different denominators, you can always multiply them. You may end up with more simplifying later on. You most often always will have more simplifying later on if you just multiply them. In this case, both 2 and 5 were prime numbers, they didn't have anything in common already. So we were gonna end up with the same thing, but yes. In fact, I'll just come up with a new one, just come up with a new one. X, there we go. Let's do plus 5 over 6. I'll do that.
Will be 30.
What?
The less common denominator,
Is what?
30.
It is 30.
Yeah.
But I'm not gonna use that. I'm gonna use what we're just talking about in class. If you don't want to take the time to find the lowest common denominator, I could take all of these denominators and multiply them together. 5 times 2 is 10, 3 times 6 is 18. I multiply those, I get 180. So this is 5 times 3 times 2 times 6. 30 is a much better choice. If you take the time to find the LCD, 30 is the LCD. So keep in mind, that's the shorter method. But if you do this way and you just use these numbers, you can multiply both sides by 180. I didn't give myself a lot of room, and I'm gonna put it out front. And I'm not gonna write it as 180. I'm just gonna leave it as the damn factors that it came with. And the reason why is when I distribute like this, I can see what I just need to multiply here. If I distribute to this one, the 5s go away. And I'm left with 3 times 2 times 6 times 4x. And then when I do it to the 1/3, I have the 3 cancels out. I have minus 5 times 2 times 6. Times of 1, but the 1 doesn't change anything. This is how I would do it if I just multiplied through by the, not found the lowest common denominator. Because it makes the following steps easier. This is easier to do in a calculator than other stuff. And sometimes you don't need the calculator, but in here, in this case, I would. Here, I've got a 2 here, so I'll cancel off a 2 there. I've got a 5, a 3, a 6 left, and I've got a 3 left on top. And finally, I would cancel out the 6 one, and I'd have a 5, a 3, and a 2, and then a 5 left that was on top. So, what does this end up being? I've got 12 times 12,
144.
144x minus 60 equals, I've got 9 times 30 is 270. Plus 10 times 15 is 150. Thank you, Josue. That is you, Josue, right? That's your voice?
Huh?
Yep, you responded, it's you.
Oh.
I'm not seeing a list of the names, I was just going by your voice, asking you who it was, making sure that's fine.
Oh, can you hear me?
I can hear you, yeah, you're good.
Okay.
All right, now, what do we do here? I
You can
agree.
subtract the 144x to the right.
I like doing that myself. I think we're all in agreement that we need to put the x's together We had two choices of what to move. I like moving that one because it doesn't really matter what side the X is on. But this way I'm left with a positive coefficient. It's 126, I think. And in that case, since I moved everything, all the X's to the right, I'm gonna move all the numbers to the left, the constants to the left. And I have minus 210. And so now I have X equals, when I divide by 126, I got negative 210 over 126. I know this simplifies. If I divide it by 2, I've got negative 105 over 63. That's divided by 2. And now 63 only has a 9 and a 7 in it.
Oh, sorry. It is 110.
The 3 goes in, right? That should,
It's
210.
110. Yeah.
210 divided by 2 is not 110.
Oh, I thought it was a 2.
Yeah, it fucked up my handwriting, sorry. Thank you, though. If this reduces more, the 105 is divisible by 3 or 7. The 1 and the 5 add up to 6, so it is divisible by a 3. So if I divide 3 into this, I get 35 times 3 on top. And 3 times 21 on bottom. Well, that reduces even more, doesn't it? I got 35 over 21, which is 7 times 5 over 7 times 3. X is just 5 over 3. So if we had used the LCD 30, we might have gotten straight to the 5 over 3. If we didn't, we might have had some hell trying to simplify. Any questions on that one? Oh. Go ahead and work on that one for a second. All right, what'd you guys get?
I'm not sure if I'm right. I'm probably not, but I got x equals -10.
Let's find out. I've got no solution. I've got -10, and I've got confused. There's 3 answers. So let's see what's going on. What should we do first?
Would you multiply the 4/3 to 6x or no?
We can. We can distribute the 4/3 to the 6x. I'm going to discourage against it. Because a lot of times people will only hit that one and then forget to do that one. You're better off getting rid of the 3, at least the fraction for now. Best off, get rid of the fractions right off the gate, right out of the gate. Let's multiply by 3. If I do it on this one, the 3 just cancels and I'm left with 4 times 6x plus 1. On the right side, I have to distribute and I get 24x minus 6. Now I would distribute. People are less likely to make mistakes when there's no fraction there. The 4 times the 6 is 24x. And 4 times the 1 is 4. And they're both the same amount. So it doesn't really matter which one I move. Even if I don't move the constants, I've got 4 equals -6. This is straight up false.
Oh, I like totally just disregarded that because yeah, I got to right there, but I didn't realize.
I know what you did. You subtracted and you left an x, didn't you?
Yeah, so I subtracted 4 to both sides, and yeah, and then I got x equals -10. I don't know.
That is a common mistake. So when they subtract, don't like just leave this whole thing minus the whole thing, it goes away. So in math, we call this a contradiction. But in terms of a solution, it means it doesn't matter what I plug in, this is never going to work. Because the x's cancel out on each side and it never works. There is no solution. However, if we do, I'm just going to edit it slightly. All I did is change the right side from -2 to 4/3. If we do what we did before and multiply both sides by 3, on the left we get 4 times 6x plus 1. On the right we get 24x plus 4. And when we distribute here, we've got 24x plus 4 equals 24x plus 4. You can actually stop there if you recognize right away that these are the same damn thing. They're the same thing. So if I start subtracting, this is going to lead to 0 equals 0. This is called an identity, I believe is the one they like to use. For us, in all intents and purposes, it doesn't matter what x is, it works. I can plug in 0 on both sides here. I can plug in -3 billion on both sides. I'm going to get the same thing. So x is all real numbers. And an easier way of writing that is x equals, you do a capital R, but you do a double vertical line on the R. That's the same thing as saying x is all real numbers, and I'm off screen. You guys ready for more? Let's switch over to complex numbers. The square root of -1 equals I. Also known as our imaginary number. Sometimes people in physics or like electrical engineers, they sometimes use J. Because they're asshats. They didn't want to get with the program. They use I for something else. I is commonly used for current in electricity, electrical equations. And so they use a different letter. So I don't know why they don't use like C for current or something better for current, but they're like, nope, we're gonna do our own shit. All right, so if we don't like the square root of -64, that's really the square root of -1 times the square root of 64, which is I times 8, or 8I. All of my I's have this curly little tail on them when I write with them in an equation. Because without error, I will, if I don't make it curly like that, I'm gonna look at it later on and think it's a fucking 1. I won't even recognize the dot at the top that makes it an I. It's just, it looks like a 1. If we have two negative square roots multiplied together, this leads, we take the square root of 4 is 2, and the negative part turns into an I. We take the square root of 9, it turns into a 3, and that negative part turns into an I. This turns into 6I squared. So what is I squared? If I started with -1 equals I, and I square both
Positive.
sides.
Positive.
What?
I don't know, maybe it's positive. Positive.
The square root and the square go away. I squared is -1.
Oh, okay.
So I'm glad you mentioned that, because so the correct answer here is going to be -6. I want you to take note that this is the correct path. Doing that. The path that leads you down the path of the dark side is multiplying these two together on the inside and saying -4 times -9 equals square root of 36. And you take the square root of 36 and you get 6. This is the dark side. Maybe I shouldn't use the dark side. I like dark side, so this is the wrong way. Because we lose the information about the negative signs. I can fit in a tiny one right here. Square root of -8. The negative part comes out and it's I times the square root of 8. And the question is, what is the square root of 8? We've got I times the square root of 2 times 2 times 2. So I've got 2 or I got 3 2s. I can take 2 of them out and put a 2 out front times the I, and it leaves that one left. So this would be 2I times the square root of 2. Sometimes the computer on the homework and other people will write 2 root 2 I, which is still correct. I think this, I don't particularly like it because it's really easy to think that the I goes underneath the square root sign. And that's why I have that little tail dropping down. So it's like, nope, this is my cutoff. The end of the square root is here, no further.
Instead of 2 times 2 times 2, we also do 2.
Yep. What else we got in this section? We got multiplying and then we got dividing complex numbers. All right. Let's look at some examples of those.
Could you show the bottom piece of the last one again? I didn't finish it.
Yeah.
No, wait, not until you tell me.
Thank you.
What's going on here.
This is just distributing and working things out. So see what you come up with.
I just have a question. Like
Yeah.
when the number has the I symbol and in that number is negative, that's gonna be positive.
The I does not cancel out a negative sign. No.
So
Just
it
leave
will
the
just-
I, like this -4i by itself is still just -4i. I is the square root of a -1, so the I is like, this means -4 times the square root of -1, that part.
yeah.
The negative can't go inside, they don't cancel each other out yet. So not quite that.
And what and if that's positive,
So we should just be distributing and seeing what we come up with.
Okay.
So if we do the 3 times the 5, we get 15. 3 times the negative 4i is negative 12i. 2i times 5 is 10i. And 2i times negative 4i, I've got negative 4 times 2 is negative 8. And then I times I is I squared. And we already showed that I squared equaled negative 1. So now I can take the I squared, replace that with a negative 1, and make that positive. That's where I can, the negatives will affect each other, where the i's affect the negative, when you have an I squared. So I just made that replacement real quick. Now we're gonna just clean up and combine like terms. I have 15 plus 8. The 2 negatives turn into a plus. 15 plus 8 is 23. And negative 12i plus 10i is negative 2i. And that's it. We do the same thing if it's in the denominator. But what we want to, like, if we have like a 5 plus I, and I've got a 2 minus I down here. We want to do the idea of the conjugate like we did with the rational expressions, where we multiply by the same numbers, 2 in the I, but we change the sign of whatever that is. So I'm gonna, if that was negative, I'm gonna make it positive. This is called the complex conjugate. And we put them in parentheses. And I got 5 plus I on top times 2 plus I. This is A minus B times A plus B now, which is, that's why we do it. Because then we've got the shortcut that equals A squared minus B squared. A is 2 and B is I. So I have 2 squared minus I squared. If we clean up the top, 5 plus 2 or times 2 is 10. 5 times I is plus 5i. I times 2 is plus 2i. And I times I is plus I squared. And we know plus I squared is really the same thing as negative 1. And I'm going to put that down here for this I squared also. It's a negative 1. So the bottom is 2 squared minus negative 1. I'm left with 9 plus 7i on top. And 2 squared is 4 plus 1 is 5 on bottom. One last little one in that line of thinking. If I have 3 over negative I, That's kind of like 0 minus I. And the complex conjugate of that would be 0 plus I. Or just I. So here we can multiply both sides by I over I. I get 3I on top. Negative I squared on bottom. The I squared turns into a -1. So I've got 3I over -1 is +1. So the answer is just 3I. So if it's not in a complete complex number form, like you don't see a real number, don't let it throw you off. Any questions? All right, let's take a break for a little bit until the next class starts. Stop recording. That there is 6 people, including myself.